Hello class, I'm Amaya Johnson, and today our lesson will be focused on partitioning rectangles into halves, thirds, and fourths. So to get started, partitioning means dividing shapes into equal parts. So let's first start with our halves. Halves means to divide a shape into two equal parts, and the shape we'll be working with today is rectangles. So as you can see, there's two parts of this rectangle, and they're equal. These rectangles divided into two equal parts. So this rectangle is partitioned into halves. This is a correct representation of a rectangle that's partitioned into halves. Our next example, this rectangle also has two equal parts. It's divided into two equal parts. So this will be a correct representation of a rectangle that's partitioned into halves. Our next example, or should I say non-example, is actually incorrect. Yes, this rectangle is divided into two parts, but the parts aren't equal, which makes it not correct because it's not equal. So this isn't a correct representation of a rectangle partitioned into halves. But our next example is two equal parts on each side. So this is a correct example of a rectangle partitioned into halves. As you can see, there is a couple ways where you can partition a rectangle into halves instead of just this way, the first way, which is the most common. So now you have thirds, and I want you to notice as we go along with the lesson from thirds to fourths how every time the number goes up, you have more parts that you're creating in the rectangle, or you're dividing the rectangle into more parts. So thirds means three equal parts. So a rectangle, to correctly represent thirds, has to be divided into three equal parts. So our first example, you have three equal parts, 1, 2, 3, each part is equal. So this will be a correct representation of a rectangle partitioned into thirds. Our next example, there's 1, 2, 3, three parts, and each part is equal. So this is the correct representation of a rectangle partitioned into thirds. However, this is incorrect. So you have 1, 2, 3, you have three parts, but these parts obviously are not even. All parts of the rectangle all parts that are divided in the rectangle have to be even to correctly represent thirds. So all three parts have to be even, just not two of them. So our next one is fourths. So fourths means four equal parts. So we're working with rectangles that should be divided into four equal parts. That's how you represent a rectangle that's correctly partitioned into fourths. So here we have 1, 2, 3, 4. We have four parts, and each part is equal. So this is a correct example of a rectangle partitioned into fourths. Our next one, 1, 2, 3, 4. We have four parts, and each part is equal. So this is a correct representation of a rectangle partitioned into fourths. We have 1, 2, 3, 4. Four parts again. They're all equal, so this is correct representation of a rectangle partitioned into fourths. We have 1, 2, 3, 4, four equal parts. This is also a correct representation of a rectangle partitioned into fourths. And then our next one is incorrect. Again, if you're going to partition a rectangle into fourths, it has to have four equal parts. These parts are not even with each other. All parts have to be even, all four parts. So this would not be correct. This is not correct. One more thing I'd like to add, as you can see up here, we have one part of the rectangle shaded, which would mean we have 1/4 of this rectangle shaded. And 1/4 means we also have a quarter of the rectangle shaded, because a quarter means 1/4. So it's 1/4 of this rectangle that's shaded, and it's a quarter. Thank you for coming to my lesson today. I hope you learned something.